Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6B, Fractions and Decimals. We're going to go over the questions at the end of Subchapter 6B, which start on page 467 and 468 in the 29th and 30th editions of Barron's SAT, including the Barron's SAT Premium Study Guide. So here we go. Question 1, page 467. A French class has 12 boys and 18 girls. Boys are what fraction of the class? Well, to find the fraction of boys in the class, we have to take the number of boys and divide it by the number of boys plus girls. In other words, the total number of people in the class. So we're going to have 12 boys over 12 boys plus 18 girls, so that becomes 12 over 12 plus 18, which is 12 over 30. We can factor out the 6 because 12 is 6 times 2, and 30 is 6 times 5, so we end up with 2 over 5. That's choice A. Question 2. So, for how many integers A between 30 and 40 is it true that 5 over A, 8 over A, and 13 over A are in lowest terms? So when you simplify something to lowest terms, as in this graphic in the upper right-hand corner, you just factor everything and you cancel all the common factors that are in the numerator and the denominator. So basically everything on the top and the bottom. If you see two of the same number on the top and the bottom, you cancel it out. So here we have 5 over A, 8 over A, and 13 over A. Well, first of all, fractions not in lowest terms unless the number on the top, the numerator, and the number on the bottom, the denominator, have no integer common factors other than 1. So, easy way to do it is just list all the numbers between 30 and 40, 30, 31, you see. And then, okay, we know 5 over A cannot possibly be in lowest terms if the denominator is a multiple of 5. So we can just take out 30, 35, and 40. So we've gotten rid of 3 of them already. So now we're kept to look at 8 over A. Well, 8 over A cannot be in lowest terms where A is divisible by 2, because 8 is obviously divisible by 2, it's an even number. So we just take out anything that's an even number that we haven't already taken out. So we take out 32, 34, 36, and 38. Alright, so that takes out all the multiples of 2, also known as even numbers. 13 over A cannot be in lowest terms where A is divisible by 13. So you might be thinking, gee John, I don't know. What is a multiple of 13 that falls within 30 and 40, if anything? Well, you know, 13 itself is 13, so 13 times 2, okay, that's pretty easy, that's 26. Well, you can add another 13 to that to get 13 times 3. Well, 26 plus 13 is 39, or you can just multiply it. 3 times 3 is 9, and then 1 time, the 10 is 10 times 3 is 30, so either way, you can find out 3 times 13 is 39 no matter how you do it without even touching your calculator. If you have a calculator, then, geez, use your calculator. So, we get rid of 39, so then all we're left with is 31, 33, and 37. That's 3 numbers, so choose C, which is 3. Question 3, page 467. 1/10 is the average, or arithmetic mean. In case this is the first of my videos you've seen where we've done an average, the reason the SATs has average and then arithmetic mean in parentheses is they, in quotes, mean the same thing. Sorry about the pun, but anyway. So that way, no matter what your math teacher taught you, whether you were always taught arithmetic mean or always taught average, you can't complain to the College Board that you didn't understand what the problem meant. So, of 1/4 and what number? So we're going to set up the equation. It's going to be a complex fraction, which no one likes. So that's going to be 1/4 plus the number over 2. So that's the definition of an average, is you add the numbers and then you divide by the number of numbers, the number of values you have. So it's 1/4 plus n is equal to 1/10. So the first thing we're going to do is multiply through by 2, so then you end up with 1/4 plus n equals 1/5, because that's 2/10 is 1/5. And then n has to be 1/5 minus 1/4, because we're going to subtract 1/4 from each side. So we'll find a common denominator, 5 times 4, okay, that's pretty easy, that's 20. So that's going to be 4/20 minus 5/20 equals -1/20, so the number is -1/20. I don't know why that made me feel weird the first time I saw it, but it's just a negative number. Anyway, and here's how to do an average. This is in sum notation. You can see 1 over n times the sum from 1 to n of all n values, or more commonly this x plus x1, x2, x8, to x sub n over n. Anyway, either way, -1/20 is choice B. Question 4, page 467. If 3/11ths of a number is 22, what is 6/11ths of that number? So you can set up the equation, just 3/11 times n equals 22, where n is the number we're trying to find. So 6/11 times n is equal to question mark, because we don't know. So the math teacher method would just be solve for n. So then you'd go, all right, well, I know that we need to divide n by 3/11, or 3/11 n, so divide by 3/11, which is the same as multiplying by 11/3. So I get 22 times 11/3, and then I have to multiply n by 6/11 to get that. That's hard to do without a calculator. I mean, if we do it with a calculator, we end up with something like this. So we go, okay, 22 times 11, and then we divide that by 3, and then, okay, we have to multiply that times 6/11, so we get 44. Okay, that's great if you have a calculator. It's a little tedious. There are a few moving parts, as I like to say, where you can make mistakes. So the SAT method, not something your math teacher would approve of, because it doesn't really show that you know how to solve for the variable. Well, it kind of does, but anyway. It's much quicker, it skips steps. Math teachers don't like it when you skip steps because that's how you make mistakes. But here it makes sense if you just take a second to realize 6/11 equals 2 times 3/11. So if 3/11 of n is equal to 22, 6/11 of n is just going to be 2 times 22, which is 44. So that's choice D. And the lesson here is you can actually skip steps if you understand what you're doing. That's why the guy who was better at math than I was in high school was able to do things faster than I was. I like to not skip steps generally just because I know I'm going to make a mistake if I'm not careful. But here, please skip the step with my blessing, because it's a contrived SAT problem. Once you see how it works, boom, just go ahead and do it. Question 5, page 467. What fractional part of a day is 12 minutes? 1 day equals 24 hours, and 1 hour is 60 minutes. I hope you know this. This is not something that really should depend on what culture you're from, or at least anywhere in the Western world. It's basically like this, and I think in the Eastern world, I'm sorry if you live in some place where they don't measure time in this way, but I digress. So we know that a day is 24 hours and 1 hour equals 60 minutes. So we're just going to set up the equation. Your chem teacher or physics teacher may have called that dimensional analysis. Basically, it's a fancy word for setting it up so the units cancel out, so you know you did the math right. Because if your units came out messed up, that means you probably messed up the math. So we have 12 minutes times 1 hour over 60 minutes. Since 1 hour is equal to 60 minutes, this is 1/1, so you can flip it and it doesn't make a difference. Anyway, the minutes cancel out, which is good. That's what we want. 1 day, 24 hours. Okay, hour and hours. Sorry, English language, but anyway, the same unit. They're going to cancel out. So we end up with basically 12 over 60 over 24. So that's going to be 12 times 1/5 times 12. Why? Because, well, all right. 5 times 12 is 60, so this 12 and the 12 that's a factor of 60 in the denominator cancel out. So we end up with 1/5 times 1 day over 24. 5 times 24 is 120. So 12 minutes is 1/120th. Anyway, it's 1/120th of a day. Boy, having trouble talking today. Anyway, so again, in case you didn't understand that, 12 minutes. Okay, minutes cancel out, hours cancel out. So all you have left is day for the unit. The 12 in the 12 minutes cancels out with the 12. That's a factor of 60 because 60 is 5 times 12. And then 1 day over 24 hours, which the hours already canceled out. So it's just going to be 1/120th, and I should have written in day there. Anyway, that's choice A. Hope you enjoy that. Question 6, page 467. 5/6 of 18 equals 5/11 of what number? Well, it's a mystery number. That's why we have Scooby-Doo and the mystery machine here. All right, of means multiply. So we set up the equation. So 5/6 times 18 equals 5/11 of n, where n is the mystery number. So then, of course, we're just going to divide by 5/11 to get n by itself. Whereas the old heart song goes, how do I get you alone? Okay, anyway, so we get 5 6 times 6 times 3, because 18 is 6 times 3. These 6's cancel out, so you get 5 times 3 equals 5/11 over n. All right, so now that means that 15 is equal to 5/11 over n, and now we're finally going to divide by 5/11, so it can be 15 times 11 over 5. I'm sure you can recognize that 15 is 5 times 3, so there's a 5 there and a 5 there. They cancel out. Oops, I didn't do the little strike through thing on the 5. You can see this 5 and that 5 cancel out, so you end up with 3 times 11, which is equal to 33, which is choice A. Question 7, page 467. Which of the following is less than 5 over 9? 5/9. Okay, let's say you don't have a calculator, or it's on the no calculator section where you can't use your calculator. Do this. So, all right, 5 6, it's easy. Well, 6 is smaller than 9, so 1/6 has to be greater than 1/9. If you wanted more pizza, you'd want it split among 6 people, you and 5 other people, not 8, not 9, which would be 8 and you. So you would definitely want to have fewer people sharing the same size pizza if you wanted more pizza. So 21 over 36. Okay, so we have 3 times 7 times 3 times over 3 times 3 times 4. So that's 9 times 4 is 36. 3 times 7 is 21. So this 3 on the top and this 3 on the bottom cancel out. We end up with 7 over 3 times 4, which is 7/12. So here's a trick you can use that works is if A over B is greater than C over D, then AD has to be greater than BC. Why? Well, because you just multiply. So I'm going to multiply and get AD here and then BC there. It's just cross multiplying. So if 5/9 is greater than 7/12, then 12 times 5, which is 60, has to be greater than 9 times 7, which is 63. Obviously that's not true, so 7/12 is going to be greater than 5/9, not the other way around. So that's 7/12 is not less than 5/9. 25 over 45, just that's equal to 5 over 9. You just divide the numerator and the denominator by 5. So 45 divided by 5 is 9, 25 divided by 5 is 5, so just no. 55 over 100, by process of elimination, this one's right. On the real SAT, once you realized why these other 3 were wrong, you know that D would have to be right. You wouldn't even have to waste time on it. If you're like me, you're probably going to check anyway just to make sure you didn't make a mistake on the other ones. So fine, let's do it. 55 over 100 is less than 5 over 9, and 55 times 9 is less than 500. It is, because 55 times 9 is going to be 9 times 50 plus 5. We're just using the distributive law. 55 is equal to 50 plus 5. We know 9 times 50 is 450, so it's just 45 with an extra 0 on the end. 9 times 5 is 45, so 450 plus 45 is 495, which is less than 500. So yes, and you can't see me, but I did not touch a calculator, I promise. I would have used the on-screen calculator if I used a calculator for that. So these are great ways you can avoid having to use your calculator, even on the calculator section. And of course it helps you a lot if it's on the no calculator section and you're thinking, how on earth am I going to do this? This is a crazy thing. There's probably a trick you can use like this to do it easily. Question 7, page 467. Okay, let's say you can use a calculator. Well, it's easy if you can use it. You don't have to bother to reduce the fractions, but you should calculate twice. Because if you hit the wrong button, memory is not cleared, etc. So, alright. So the first thing you want to do if you have a calculator is you're going to go, hey, what the heck is 5 over 9 in decimal form anyway? So it's 5 over 9, so it's 0.55555555556. Okay, so it's really just 0.55555, and it just keeps repeating till the end of the horizon, whatever. It goes on forever. Alright, so that's the number that we need something. One of these has to be less than it. So we just go, okay, first one. Clear it out. You want to go 5 over 6. Doesn't hurt to hit clear twice just to make sure that you cleared out your memory. Especially true with iPhone calculators. I find that happens all the time. Not that you can use your cell phone calculator anyway, but just make sure your memory is clear and just do the calculation twice to make sure you have it right. So here this is 0.83333333 repeating. So we know A is not right because that's considerably more than 0.5555555. Alright, so then 21 over 36, we don't even have to get it in lowest terms, even though we just did in the previous slide. So 21 over 36, that's 0.583. Well, it's closer, but it's still greater, so that doesn't work. Alright, so C, it's 25 over 45. If you're pretty quick you can realize, hey, wait a minute, that's the same as 5/9, but let's say you didn't. Again, you just go 25 over 45 like a robot. Okay, blah, blah, blah. Let's make sure I did it right because John told me to do this. Okay, so it's 0.5555556. Okay, good. So you know it wasn't just you hit a button wrong or a memory problem. So that's exactly the same as 5/9. And this is probably when it'll hit you and go, oh, I get it. They're the same number. Dope. All right, so D, 55 over 100. It's 0.055. You could do that in your head, but again, let's say you're just stressed or you're not sure, you're feeling, fine. You just do it on your calculator, 0.55, and that's just slightly less than 0.5555555, repeating till the end of time, so it's right. And that's exactly the kind of question the College Board people would ask you. So let's go on to the next question. Question 8, page 467. Which of the following is or are greater than x when x equals 9 over 11? Number 1, 1 over x. Well, that's really easy. You just take the reciprocal or just flip it in common terms. So we just go 9 over 11, multiply it, flip it over. We get 1, not 1, we get 11 over 9. So 11 over 9 is greater than 1, which means it's greater than 9 over 11. So yes. And 2, x plus 1 over x. Well, remember, x is still 9 over 11. 1 is 11 over 11. So when we add them together, we get the sum of 9 plus 11 over 11. That's 20 over 11. Then we have 9 over 11 is the denominator, because that's still just x. 20 over 11 divided by 9 over 11 is 20 over 9. And that's greater than 1, which also means it's greater than 9 over 11. So yes. So 3. X plus 1 over x minus 1. Well, 20 over 11 is, it's still the same as it was in section 2. It's section 3, same deal. So we have 9 minus 11 over 11 is x minus 1. Why? Because 11 over 11 is 1. X is 9 over 11. Since we're subtracting 1, it's 9 minus 11 over 11. That's 20 over 11 over negative 2 over 11, so that's going to be 20 over negative 2, which is equal to negative 10, which is equal to 9 over 11, so no. All right, so question 9, page 468. Which of the following statements is true? 3/8 is less than 4/11 is less than 5/13. 4/11 is less than 3/8 is less than 5/13. 5/13 is... Okay, so we can see they're all variations on the same fractions, 3 over 8, 4 over 11, 5 over 13. So they want to know what's the smallest, what's in the middle, what's the biggest. So that's really easy to do with a calculator, but what if you don't have one, or it's the no calculator section, or what have you? Well, 3/8 is less than 4/11 is less than 5/13. First thing we can do is check to see if 3/8 is less than 4/11. Well, we cross multiply as we did before, so 3 times 11 is 33, 4 times 8 is 32. Is 33 less than 32? No. 33 is greater than 32, so we know that 3/8 has to be just a little bit bigger than 4 over 11. And then check 4 over 11 is less than 5/13. Well, 4 times 13 is 52. 5 times 11 is 55. 52 is less than 55, so yes, 4/11 is less than 5/13. How about 3/8 less than 5/13? Doesn't hurt to check that. If you check that, then we're going to know the order. So 3 times 30, not 3 times 30, 3 times 13 is 39. 5 times 8 is 40. 39 is less than 40, so it all checks out. So yes. So then once we know that, all we have to go is, okay, then we know that 3/8 is going to be between 4/11 and 5/13, and that actually is answer choice B from the work that we did above. Pretty simple. Question 9, page 468. Okay, let's say we do have a calculator to do the same problem. All right, with a calculator, we can find out that 3 over 8 is easy. 3 over 8 is 0.375. Those are worth knowing that 1/8 is 0.125. And so 3 times that is 375. And also, if you want to do 5 over 8, so that's 0.625. Those are worth knowing for the SAT and just generally for anywhere you have to do arithmetic. All right, so let's say 4 over 11. Okay, so that's 0.36363636. Okay, so then we know that's going to be less than 0.375, so it's less than 3/8. And 5 over 13 is 0.3846, and it just looks like, okay, looks like it just keeps repeating 384615, 384615, 384615. Okay, so it's approximately 0.3846. I couldn't find the little squiggly equal sign that means approximately equal to, so I just had to write approx there. Anyway, so then we know B is true because we just 4/11, 3/6, 3/8, 3/7, 5/13, 3/8. So B is very obviously true. And we move on to the next question. All right. Question 10. If A equals 0.99, which of the following is or are less than A? All right, so here we're entering the upside down, as in Stranger Things, because when 0 is less than A is less than 1, we enter the upside down where the normal rules don't apply. For example, the square root of A is 1/2 when A equals 1/4. Normally that's not the case. If you have the square root of 4, it's equal to 2. So the square root is larger when you're dealing with a fraction that's between 0 and 1. So it's positive, but it's smaller than 1. So the same applies to A even if we don't have a calculator. So A is 0.99, that's just barely, it's 1% less than 1. And so the square root of A is approximately 0.995. That's really easy if you have a calculator. You just go, okay, 0.99, what's the square root? Yeah, 0.99498, so just 0.995. Anyway, you just have to know that if it's less than 1, it's going to be larger. So cannot be cannot be 1, rather. Okay, 2A squared, well, okay, we go 0.99 times 0.99. We get 0.9801. So 2 is less than A. And then, all right. So the next thing we do is 3. 1 over A, well, okay, that's 1 over 99 over 100, so, 0.9. So if you did it without a calculator, you could just go, well, that's 100 over 99. You don't have to be a math genius to know that 100 over 99 is a little bit bigger than 1 because the numerator is bigger than the denominator. But if you do, you can just go 0.99, and then you can just go 1 over that. So it's 1.01010101011. So it's not less than A. It's just slightly more than A, so it's greater than 1, so it's greater than A. So the answer is C, that's 2 only. Okay, question 11, page 468. All right, for the final step in a calculation, Paul accidentally no, he didn't. All right, talk about miscalculations. Anyway, for the final step in a calculation, Paul accidentally divided 1,000 instead of multiplying by 1,000. What should he do? Well, let's call the number before that misstep C. So he got to C. Paul wanted C times 1,000, but he divided, so he got C over 1,000. So the first thing we're going to have to do is multiply C times 1,000. We're going to apply C over 1,000 times 1,000. So we just take C over 1,000, which you have here, multiply it by 1,000 to get C back. So now we're going to multiply C times 1,000 to get our final answer. Since we multiplied by 1,000 twice, we multiplied by 1,000 times 1,000, which is equal to 1,000,000, or 1,000,000. If you don't believe me, fine, I'll get the calculator out. So here's 1,000 times 1,000. Okay, that's 1,000,000. So another way you could do it if you like to work with exponents is, it's 1,000 is 10 to the 3 times 1,000, okay, then it would, which is also 10 to the 3, and you just go 10 to the 3 times 10 to the 3, which is going to be 10 to the 3 plus 3, which is 10 to the 6, which is 1,000,000. And another neat thing to do here is you can just go, well, all right, we know that 10 is 10 with, 1 with 1 0 after it. So 1,000 is 1 with 3 zeros after it. And 1,000,000 is going to be 1 with 6 zeros after it. So you can see where they put these commas. Okay, this is 100,000s, this is 1,000,000. So you can just go 10 to the 6, go, okay, I write 0 6 times before I write the 1. 1, 2, 3, 4, 5, 6. Boom, that's 1,000,000. All right, irredeemable miscalculation. This is a bridge, I think it was in Washington State or whatever. It basically blew down very shortly after it was built, because unfortunately the wind got it to shake at just exactly the right, whatever vibration harmonic point, the natural oscillation that would cause it to fall apart. So this is that one where you can see the old-fashioned cars on it and the thing's shaking apart. So what you thought was your greatest achievement completely annihilates your career in a matter of minutes. So make sure you get your calculations right when you're working on things. Question 12, page 468. One day at Central High School, 1/12 of the students were absent and 1/5 of those present were on a field trip. So if the number of students staying in school, that is, they were marked present and on the school campus, was 704, how many students are enrolled at Central High? So let's set up the equation here. So let's have E equal to the number of enrolled students at Central. So if 1/12 were absent, 11/12 were present. So 11/12 over E were present. So since 1/5 went on a field trip, 4/5 stayed in school. So 4/5 times 11/12 equal E stayed. We quickly see that 4/12 is equal to 1/3, because you have a 4 on the top and a 12 on the bottom. So we have 1/3, and then there's 11 and the 5 that are on the top and the bottom. So 1/3 times 11/5 E equals 704. 11/15 times E is 704, and 15/11 times 704 equals E. So hopefully this is on the calculator section, so you can just plug in the numbers with the calculator and get something like this. You get 15/11, and you're going to multiply that times 704, and voila, you get 960, and you're done. Okay, but let's say they just do something really fiendish. It's your unlucky day, and this is on the no calculator section. What do we do? Well, we could eliminate answers. Oh, wait a minute, this is a grid question in the book, so what do we do now? Well, we know that 15/11 times 704 equals E. This is a contrived SAT problem, so it's not really that hard if you know the tricks. And one thing they do try to do on the SAT is they try to mirror reality to some extent. So high schools don't have partial students. That is, the answer is not going to be that it has 938.625 students. Students are whole numbers. And yes, I know that's South Park where they have the guy who doesn't have any legs and they call him Happy. He still counts as a whole person, okay? That's mean. Why'd you say that? Alright, I'm kidding. Anyway, question 12. Page 468 continued. So that means 704 must be divisible by 11 since 15 isn't, and the result has to be a whole number. Alright, well remember 11 times any digit is just that digit twice. So it's going to be 5 times 11 equals 55. So let's see. 60 times 11 is equal to 660, because 60 times 10 is 600, 60 times 1 is 60. So we're getting close. Well, alright. The only multiple of 11 that ends in 4 is 44, so hey, why don't we try that? 11 times 60 plus 44, well, that's going to be 660 plus 44. Hey, that's equal to 704. Didn't even have to use a calculator. So then we know the number is 64 because 44 over 11 is equal to 4, so it's 60 plus 4. So we know the number is 64. So the answer is 64 times 15, and then we can just use the distributive property again. 64 times 15 is the same as 64 times 10 plus 5. So 64 times 10, we have that here. That's 64 times 10 is 640. 64 times 5, well, alright, since we know that 64 times 10 is 640, and we know 5 is half of 10, well then, alright, all we have to do is take half of the 640, and that's 320. That's pretty easy. So the answer is 640 plus 320 equals 960. It's a lot of work, but you can actually do that in the time the SAT allows without really messy multiplication you probably haven't done since 5th grade if you try to write it out the way that you learned how to do multiplication by hand when you were in 3rd, 4th, 5th grade, and so on. So the distributive property is our friend. This is also a really good way to figure out a 15% tip, because it's easy to find 10% of a number. You just take 1/10 of it, and then you just add half of the 1/10, and voila, you have yourself a 15% tip. Question 13, page 468. What's a possible value of x if 3/5 is less than 1 over x is less than 7 over 9? So there are at least 2 different ways to do this. My favorite way is just to find the lowest common denominator of 5 and 9, which is 45. So 27 over 45 is less than 1 over x is less than 35 over 45. So we're just going to multiply 5 times 9 because 5 and 9 don't have any common factors. So the lowest common multiple is just 5 times 9. Alright, so 3/5, multiply that by 9, 5 times 9 is 45, 3 times 9 is 27. Alright, so 9 times 5 is 45, 7 times 5 is 35, 27 over 45, 35 over 45. So that's just going to be 1 over x has to be something in here. We know that 1 over x has to be equal to something over 45. Whenever I do this problem, I just pick 30 over 45 because it's really easy. So then one value of x would just be 45 over 30. We just flip it, and that's 3/2. That's easy to grid in, no problems. So the math teacher way to do this would be take the inverse of all the fractions and then realize that if 3/5 is less than 1 over x is less than 7 over 9, when we're flipping it, you have to change the orders, because if 7 over 9 is greater than 3 over 5, which it is, then 9 over 7 has to be less than 5 over 3, and x is still going to be in the middle, just like 1 over x was still in the middle. So we find the lowest common denominator. That's going to be 7 and 3. Again, there's no common factors, so 7 times 3 is 21. Okay, so we have to multiply 7 times 3, then we have to multiply 9 times 3. That's 27 over 21. And then 5 over 3, okay, 3 we're going to multiply by 7, so 5 we multiply by 7. That's 35 over 21. 5 times 7 is 35, 3 times 7 is 21. So x is going to be something between 27 over 21 and 35 over 21. We can pretty quickly just use our calculator, assuming that we're allowed to use it, and just go 27 over 21, which is 1.2857, blah, blah, blah. So I would just round it up to 1.29. And then, okay, 5/3, well, you should be able to figure that out, but in case you can't, 5 over 3 is 1.66666, so 1.67. All you need is a number in between, anything in that range. So again, I would probably just put 1.5, but you can put whatever you like. Okay, question 14. If 7a equals 3 and 3b equals 7, what's the value of a over b? Well, this one's straightforward and easy except for one twist. You want to solve both equations to get a equal to 3/7. Because you can see all you have to do to get a by itself is divide both sides by 7, so you get a equals 3/7. 3b equals 7, okay, we just divide both sides by 3, so b is equal to 7/3. So the twist is many students will multiply instead of divide, so you're going to think, oh, it's a contrived SAT problem. I get it, the 3/7 and the 7/3, you just multiply them and they cancel out to 1. Oh, ha ha ha, those tricky people. Yeah, they're a little trickier than you thought even, because while that's a usual good instinct, it's not good here because you're dividing. So a over b is 3/7 over 7/3, and of course when you divide by 7/3, it's the same as multiplying by 3/7, so you get 3/7 times 3/7, which is equal to 9 over 49. Grid that in and remember to check your work carefully. Question 15, page 468. If a is equal to the set containing 1, 2, and 3, and b equals 2, 3, 4, and c is the set of all fractions whose numerators are in a and whose denominators are in b, what is the product of all the numbers in c? So this one isn't really that hard, it's just tedious and detail oriented. So first you want to set up the problem carefully and methodically. So you want to go through a in order, 1, 2, 3, with each element of b under each element of a before moving on to the next element of a. So we go 1 over 2, 1 over 3, 1 over 4. So 1 over 2, 1 over 3, 1 over 4. Okay, then we start with 2. 2 over 2, 2 over 3, 2 over 4. Then we go 3 over 2, 3 over 3, 3 over 4. So first thing we're going to do is remove the 2 over 2 and the 3 over 3 before we multiply, because they're just 1, so they're not going to change the result. So, and then we just cancel out the numbers on the top and the bottom for the same reason. They just multiply through to 1. So we have a 2 here, okay, and a 2 there. 3 here, 3 there. Okay, 4, there aren't any 4s on the top. Okay, so here's another 2, there's another 2, those cancel out. Here's a 3, there's another 3. Boom, those cancel out. So then we have a 4, there's still no 4s on the top. Okay, well everything canceled out, all the 2s and all the 3s, so literally all we have is 1 over 4 times 1 over 4 times 1 over 4, which is equal to 1 over 64. So grid that in and be happy. So for the best results, you want to use the Barron's SAT 30th, and that includes the Premium Study Guide. Either 30th edition is fine, or the 29th, or even the 28th edition, which I believe is the Barron's new SAT. So this video, in case you haven't figured it out by now, covers pages 467 to 468 in the 30th edition of Barron's SAT, but the page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous edition. You shouldn't use an edition older than Barron's new SAT. It'll say Barron's new SAT on the cover from 2016, or maybe it came out in late 2015. Doesn't really matter in any event. They came out with that for the current version of the SAT, which was called the new SAT a few years ago because it was new. So, not everything in the book is in these questions. Please read the book. You can get older editions of this book, like the 28th or 29th edition, cheaply, if not for free, from used booksellers, kids who've already taken the test, public libraries. They often sell or give away old editions. Literally, I've bought old SAT books for a dime at public libraries before. So, or you can borrow the current edition from the library. If you do plan to borrow a library copy or go buy a new edition, I suggest you start early. One, you really should, because you're not going to be able to learn all this in 1 or 2 nights or a week or whatever, unless you're already really, really good and all you need to do is do a very superficial review. And also, of course, there's just no worse feeling than needing a library book that someone else has checked out, or trying to buy a review book that's sold out. And, you know, even with Amazon Prime 2-day delivery, that might not be in time if you're just starting the night before the test or something like that. All right. So, oops, went up, okay, but did you find this video useful? Alright, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube does not let me have any ad revenue, doesn't give me any share of it, unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers, and for those reasons, you are not only welcome, but encouraged to share links to this video, put it in your playlist, whatever you want. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism. You know, trolls or things that are off topics, you know, spammers, disturbed people. People who just decide that they have something that they just really, really need to say in my video comments that, no, they don't. Anyway, contact me. My cell phone number is 415-623-4251. You can email me at john@johnlinneball.com. Mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. And if you have a copyright issue, I know we skipped it before, but I wanted to cover it here, is you think that I've used something of yours that's copyrighted, please contact me. I would be glad to discuss it with you. I'm pretty sure anything I'm using is completely fair use, but anyway. In any event, thanks for watching. If you need more contact information, there's more coming up. Contact me on Facebook. You can get me at Facebook at facebook.com/Linneball Tutoring. Instagram.com/John Linneball Tutoring. Phone 415-986-7355. Email john@johnlinneball.com. Website is johnlinneball.com or johnlinneballtutoring.com. And testpreparation.locals.com is my locals page where you can support me, and I have a lot of the same content right now, and well, actually all the same content as my YouTube channel, but I will be putting up exclusive subscribers only content very shortly. Alright, hope you enjoyed that. Have a nice day.